Hello, my cool people. So today we are talking about trigonometric functions. So we're going to start with some basic trigonometry. So we're going to have Pythagoras' theorem, trigonomic ratios, and the sine and cosine rules. Then we're going to move into graphing, how you graph trigonometric functions. And then we're going to go into an introduction to radians, trigonometric equations, and we're going to expand and talk about trigonometric identities, and then finally end with the reciprocal trig functions. So that's what we're covering today. So this is Pythagoras' theorem. It's one of the most famous theorems in all of maths. And what we say is that we have a right-angled triangle. And in this right-angled triangle, the length of the side A and the side B will, if you square A and you square B, you will get the square of the hypotenuse, which is the longer side of this right-angled triangle. It's the side opposite the right angle. And so you can obviously rearrange that to C equals A squared, equals the square root of A squared plus B squared. This applies to all right-angled triangles, that is, triangles with one right angle in them. And so then after that, we're going to talk about some trigonometric ratios. So I want you to consider this angle here. And this side is the side opposite to the angle. This is the side adjacent, so right next to the angle. And this is the hypotenuse, like we said before, the longest side. And we have some rules. So I want you to say the term saw, ka, toa. This is the best way to remember them. So you've got sine, cosine, tangent. And so sine, the sine of theta, is the opposite over the hypotenuse, saw. The cosine is going to be, the cosine of theta is going to be the adjacent over the hypotenuse, co. And then the tangent of theta is going to be the opposite over the adjacent, toa. And yeah, so definitely soca toa is the easiest way to remember those. And those are your three trigonometric functions, trigonometric ratios. They are sine, cosine, and tangent. Sin, cos, tan. So now we're going to talk about the inverse functions. So if you've got sine theta and you want to return to sine and you want to return to theta. So you've got sine theta and you want to return to theta. You've got the cosine of the angle and you want to return to the angle. What if you've got the tangent of the angle and you want to return to the angle? Well, you're going to use these inverse functions. So the arc sine, the inverse sine of sine theta is theta. The arc cosine of cosine theta is theta. The arc tangent of tangent theta is theta. So it's a way of going backwards from the sine of the angle to the angle, from the function of the angle back to the angle. You use the inverse. Okay, now these are great. This is the cosine rule. So remember Pythagoras. Let's just go back. So here we had a squared plus b squared equals c squared. It's a great rule, very easy. But this only applies to right-angled triangles. Well, what if you've got another triangle? What if you've got a triangle where there is no right angle? Well, in this case, we've still got our c squared equals a squared plus b squared. But then we've got this term here. So imagine we're looking at c squared down the bottom here. So a squared plus b squared. Then you're also going to subtract negative 2ab cos c. So if c was 90, well, cos of 90 is 0, so this term would go away, and that's where Pythagoras' theorem actually comes from. But in this case, c isn't 90, so you're going to have to use this equation instead. And yeah, here's a problem done with it. As you can see, you just plug in the numbers, chuck it in your calculator. Easy peasy, lemon squeezy. And now we've got a sine rule question. So the sine rule is, the purpose of the sine rule really is, what if if you're missing one of the angles or you're missing one of the sides, but you've either got two of the sides or you've either got two of the angles. So let's say, for example, you've got a equals 30, little a equals 5, and b equals 10. Well, I want you to try this out. You just use this equation here or this equation. They both get you the same answer. And just solve for b. Give that a shot. You know how to rearrange equations now. You've got this. Your graphics calculator will help you. Okay. Now, Well, let's talk about area. What if we want to get the area of this triangle? So you guys know the area of a triangle, half base times height. You learned this back in the day. Well, what if we don't have the base and the height. Now we have two sides. We have A and B, and we've got this angle here, C. So we've actually derived it here. Derivation. Well, let's look at this height here. So the height, it's at right angles to the base. Okay, this line here is our height. So sine C equals opposites. That's our height. So sine C equals height over hypotenuse B. So sine C equals height divided by B. Okay, so height equals B sine C. That's cool. Okay, so we've got half base equals A, half A multiplied by B sine C. Oh, well, there we go. We've got our equation. Easy peasy. Derived. It's that easy. You just had to define the height. You guys could have done that yourself. So this table, I would like you to write this table down right now. This table is going to help you out. This has all the values that you're pretty much ever going to be asked in questions. If they want you to solve it yourself, they're going to give you one of these angles. And this is the sine of the angle, the cos of the angle, and the tan of the angle. This is basically all you need to know. All right, write this down. This table will get you through trig. You're going to want this table in every exam that you've got. Awesome. All right, let's talk about graphs. So let's talk about the sine graph. So sine, that was opposite of hypotenuse. Let's go back. So sine was sine was this angle here. It was opposite divided by hypotenuse. Let's think about this. All right, let's go to our table. Let's say theta is 0 degrees. So that means basically you've got a flat line. Well, sine theta, that's going to be 0. Okay, now what if we have 30 degrees? It's a bit bigger. Okay, now if it's a bit bigger, then you're going to have opposite. So obviously, opposite is still going to be quite small, but hypotenuse is going to be larger. So it's like just going up a little bit. So you're getting, for sine 30, you get 1 over 2. Okay, and you can see that it gets, the sine will actually get bigger as the triangle gets bigger. So as the triangle approaches 90 degrees, the sine, the opposite divided by the hypotenuse, is going to get larger. So it gets larger and larger as it approaches 90 degrees. Okay, so let's have a look at this. All right, so we've got sine theta now here. So sine theta, let's start at 0. So at 0, all right, so we're at 0, 0. You can see 0, 0. And then, okay, so theta is going to get larger, larger, larger. See, it hits 90 degrees and then it starts decreasing, increasing, decreasing. And so this would be about, so if this is, let's say, 90 degrees, then this right here, it's going to hit 0 at 180 degrees. And then what happens is it actually goes and does this backwards. So it's going to go, okay, now we're at negative, so this will be negative 90 degrees. And then we come back up. Cool. Now cos is actually just the sine function, but it's shifted. So it's, as you can see, it's just been shifted to the left. And that's, if you imagine, now let's just shift all these values. So starting, yeah, cool. And this is tangent. And again, that's just a mapping. So tangent, we basically just get these values and we map them onto this function. All right. Now, I want to talk to you guys about the unit circle. And the unit circle is defined in such a way that the y-coordinate is equal to sine theta and the x-coordinate is equal to cos theta. And that's a great way to derive all these functions. Now let's talk about the radian unit of measurement. So the radian, what the radian is basically, we want to get this arc length. How do you define this arc length? Well, so what a radian is you're going to define the difference between the arc length and the radius. So if you had if your radian angle was 1, that would mean that your radius is equal to your arc length. So that would mean that this radius is the same length as this arc. So it's the ratio between this radius and the length of the arc. And that's how you get C. So for any arc, so consider that the arc length was the entirety of the pi. So it's the entirety of this circle. Well, if the radius was 1, then you would see that the whole length of the arc length would be 2 pi. But if the radius is 2, then the arc length would be 4 pi. And you can convert between radians and degrees pretty easily. So radians are just degrees times 2 pi over 180. And degrees are just radians times 180 over 2 pi.
This is the unit circle here, complete with all the radian measures. Now remember that the y coordinate is the sine and the x coordinate is the cosine.
Okay. Now, once you graph these, the graphs are a little unclear in degrees, but now let's have a look at them in radians and you can see they're a lot clearer. So you basically get this oscillation. So if we start at 0, 0, we can see that sine is going to go and it's going to go up to about pi on 2 radians. That's where it's going to have its maximum. And then it's going to come down and it's going to hit 0. So this is the line of 0 right here, and it's going to hit 0 at pi radians. And then it's going to keep going down until 3 pi on 2 radians. That's where it's going to hit its minimum. And it's going to keep oscillating like that. And cosine is shifted back. So it's got this shift here. And so cosine is actually going to be at 1, at 0, at 0 radians. But then when it hits pi on 2 radians, it's going to be on 0. So you can see there's a shift by pi on 2 radians either way. And the table is a lot clearer once you have these, once you do it in pi, in radians, you get some much nicer numbers. Okay, let's talk about the equation for a sinusoid. So a sinusoid can be defined by A multiplied by C, x plus C, or A, and then we've got our sine function, x plus C plus D. So what we've got is we've got the A, we've got the amplitude of this. So if A is 1, then you're going to have a height of 1. But if A is greater than 1, you could have a height of anything. A will define the height, and that is the distance between 0 and the top of this graph. Now C is the shift. So like we said, if we wanted to turn this sine into cosine, we could make C equal to pi on 2, and then this would be shifted forward pi on 2, and it would look just like a cosine graph. So sine x plus pi on 2 is cosine. And then we've got D. So D is the vertical shift. So let's say, okay, sure, this has got an amplitude of 1, but what if I just add 1 on top? Well, then it's going to have a height, then the top is going to hit 2, but the bottom is going to be at 0. So you're just, so I guess the best way of looking at A is half of the distance between the top and the bottom. And so if you have a shift of D, the distance between the top and the bottom is still going to be maintained, even if the whole graph is shifted up. All right, now let's talk about trigonometric identities. So I want you to write down every single trigonometric identity on this screen, because these trigonometric identities are absolutely essential and you're going to use these in equations all the time. So write them all down, please do. Basically, this is trigonometric algebra. You're going to be doing a lot of rearranging of equations and substituting these in to get solutions. And here's some more. You need all of these, so write them all down, okay? These are your half angle identities. These are called the angle sum identities. Okay, you're going to use all of them. Let's actually just try and go through a proof of one, because a lot of what you're going to be doing is algebra of these, but you're also going to be having to prove them yourself. So let's try and prove one. So consider, let's try and prove, we could basically prove all of these, but let's just consider a proof. This graph here, you'd have to draw. A lot of the time when you want to prove something, it's best to just draw it out. So this graph here can prove all of these, but let's just do a proof for sine alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. Okay, okay guys, let's do this proof. So we want to find sine alpha plus beta. So that's this angle plus this angle. So it's this angle here. So sine alpha plus beta, so that's going to be, so we've got opposite over hypotenuse. So that's going to be this length downwards from the top to the bottom over 1. So, okay, so sine alpha plus beta is going to equal this length here. Well, this length here is the same as this length here. So really, like you can look at the picture and you can see, oh, okay, sine alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. Okay. All right, but how did we get here? Let's break this down a bit more. How did we get to this side here? Well, we'll start with this red triangle. So you've looked at this picture and you see this picture, if everything in this picture is true, then sine alpha plus beta equals cos alpha sine beta sine alpha cos beta. So I just need to explain why this picture is true. Let's start with the red triangle. So the red triangle, all right, so sine beta, okay, so that equals opposite over 1. Oh, that's sine beta. Yeah, okay, all right. Cos beta, okay, cos beta divided by 1. Okay, that's true. All right, so the red triangle is true. All right, what about the blue triangle? So we're saying, let's do sine alpha, so that's going to equal opposite over cos beta. So what you're saying is that the opposite side divided by cos beta is going to equal sine alpha. So that's like saying that opposite divided by cos beta equals sine alpha. So I guess if you multiplied the opposite by cos beta, so yes, so opposite divided by cos beta equals sine alpha. So I guess if you multiplied opposite by cos beta, you would get sine of alpha. So sine of alpha equals opposite over hypotenuse. Well, if this is true, okay, sine alpha cos beta divided by cos beta equals sine alpha. Okay, so this triangle is also true. All right, we know this triangle is true. Okay, now we need to prove this triangle. Okay, so we proved the red triangle. Okay, let's prove that this triangle here is true. So opposite over hypotenuse. So sine of alpha equals opposite over hypotenuse. So, okay, so sine of alpha equals opposite over hypotenuse. So if this is true, then opposite sine alpha sine beta divided by hypotenuse would equal sine alpha. So if we divide sine alpha by sine beta, we will get sine alpha. So we know this is true. What about this side? So the cosine of sine alpha. So that's what we're saying is that the cosine of sine alpha equals adjacent divided by hypotenuse. So we're saying cosine alpha should equal cosine alpha sine beta divided by sine beta. Yeah, cosine alpha does equal cosine alpha. All right, so we know this is true since all of these pictures are true. Everything in the picture is true. We can see that this picture proves this identity. We can see that sine alpha plus beta equals opposite over hypotenuse equals cosine alpha sine beta plus sine alpha cos beta over 1. So this picture proves that. And if you look at this picture, you'll see it actually proves every one of these identities. Don't worry about the tangent identities. This picture's not a great proof for them. But for the sine and cosine identities, this picture, you can look through it and you'll be able to find a proof for each of those. So here's an example of a question you'll get about trig identities. So let's say you need to prove that the cosine of 2 alpha equals cos squared alpha. Take sin squared alpha. Well, hold on. Cos 2 alpha, that equals like cos alpha plus alpha, because alpha plus alpha is 2 alpha. Okay, we got that. That's easy. So the left-hand side equals cos 2 alpha equals cos alpha plus alpha. We just did that. All right, cos alpha plus alpha, that's like cos alpha plus beta. Oh, okay, so we can just use that angle sum identity. Ah, proved. Easy. All right, sweet. Reciprocal functions, these are awesome. So basically, imagine we've got cosine here. Well, 1 over cosine. So that's going to be, if we imagine cosine, 1 divided by cosine. So the secant x is the reciprocal of cosine. That means it is 1 divided by cosine. So if you multiply this equation here, this blue line, the secant, by, if you multiply this blue line by this brown line, you'll get 1 at every point along the line. So that is what these do. These are reciprocal functions. The cosecant equals 1 over sine, and the cotangent, the cot, equals 1 divided by tan x. Looks a lot like tan x. All right. All right. So that is the end of my presentation. Now that is a big one, so I would like you guys to go back, rewatch it, go slowly, pause it, whatever you need to do to get that, let that sink in. This is one of the most important topics in all of mathematics. I would like you to really sit with that and let it sink in. All right, thank you so much for watching. Thank you so much for watching, and I'll see you next time.